Hi, my name is Phil Fearon, and this is the second part in the series on the Saxonica documentation system. So just as a recap, this is a documentation system that uses the Saxon Client Edition processor. So that's running in the browser, and it's an XSLT 2.0 processor. So the whole of this documentation system is actually coded in XSLT 2.0, with the exception of about 50 lines of JavaScript that are used for non-standard extensions, or to take advantage of non-standard extensions in different vendor browsers. So this is the documentation system that you'll see, and what we've got is the look and feel of a typical desktop application, yet with code that is residing in the web. And the way that this is achieved, I'm just using page up and page down keys to show the responsiveness of the application, and also just to highlight that there's just a part of the HTML page that is being rendered or re-rendered each time that I navigate to a new part of the documentation. So if I click on that link there, it's just this block here that has changed, and the rest remains the same. And we can see confirmation of that as well when we look at how this URL here stays constant, and it's only the state information that follows the hash that changes, and it changes each time we navigate to a new page if you watch it as we go through. So that is the area that I'm going to be concentrating on today, about how we manage that change of state within the XSLT process, and how we deal with side effects. So if I switch to a slide of taking a high-level view of the architecture. So what this shows is that we've got transforms that always happen from left to right, as I'm showing here, from within this XSLT controller. And what this controller is doing on the left-hand side, it's listening for events. And there are two significantly different types of events that are of interest. One is a change in the hash, and that's just what I've been speaking of here, where this part of the URL changes either in response to a user action or in response to a system itself. So that's the hash change event, but the other types of event that can happen are within the DOM. So if a user is going to click on a button or click on a hyperlink within or what appears to be a hyperlink within the document, in fact what's happening is that on-click event will fire, and that on-click event is actually handled within the event handler. There aren't actually any hyperlinks within the documentation set except those that link to websites that are outside of the application, that are on different domains. So it's important for the architecture to keep distinct the event handling side of things from what is actually going on beyond that after the event takes place. And so hopefully this diagram illustrates a bit of that. So when there's a hash change event, so if I just bring up my highlighter. So if there's a hash change event, so that happens here, then there's logic within the XSLT that handles that event, and it will bring about a corresponding change in the view to mainly the main story part of the documentation page, but also small changes to the tree view and breadcrumbs view as well to reflect that change. So that happens when the hash changes. And what happens when the user clicks perhaps on an item within a page, perhaps something that appears as a hyperlink, or it might be clicking on an image, then the DOM event handler within the XSLT processor, that takes precedence then, and that will handle that click event. But instead of actually responding in a direct way by changing anything to do with the appearance of the document, all it does is initiate a hash change. So what this then allows us to do is rely on the built-in hash change event handling capabilities that are already there. And so as soon as we change the hash using code, it's as if that change has happened externally by some other system, but it's still handled in the same way. So that hash change is fed back through to the hash change event handler, and it's only that which changes the view. So the important part, if I just do it in another color, just to show that this is a bad thing, we don't want anything happening there between that changing the hash and changing the view, because that would be disruptive to the rest of the application, and it can cause problems with managing state. So it's important not to have that link. So I'm going to get rid of those annotations now. So hopefully that describes most of what's going on. It's also important to understand that when you're changing the view, you're potentially causing events to occur within the DOM, and so you have to be prepared to handle those events in your DOM event handler. But they're not going to cause things like click events, but they may cause resize events and the like. And for this application itself, there isn't that concern of side effects caused by the change view, but it's something to be aware of when you're developing perhaps more sophisticated applications that have got a higher level of user interaction, perhaps in games and so on. Okay, now we've looked at this at the high level, at the logical view really. We can have a look in more detail at some of the XSLT code that is used for this. So if I move to the next slide, this is how we handle a system event, in fact specifically the hash change event that I was just speaking of earlier. So at first glance it looks like a standard template with a match pattern, but in fact we only have to look a bit closer and we can see that the match pattern is in fact an extension function, and it's relying on a Saxon-CE extension function that returns the window object for the browser client system. So that's what we're matching on, and we're looking for an event that is being raised by that window object, and this is the method that we use for doing this, and we're using a special extension again for the mode that allows us to use an XSL namespace to identify that what follows that is actually the name of an event rather than an internal mode for the XSLT code itself. Excuse me, I haven't shown the namespace declarations in this code, but that's something that we can look at later on. It's all in the Saxonica documentation. And then actually within this I'm just making, I'm delegating that to a further named template that is actually going to process that change in the hash. And there's no state information that needs to be transferred across here, but it's important to note that the context item for within this template is actually the window object. It's the item that was matched. So if you're using another extension function, because you can use any extension function here that is returning a JavaScript object, and whatever function you use, that whatever's returned will be the context item within that template, or at least at the start of that template. So that's managing a hash change event. Let's quickly look at handling events within the DOM. So typically an on-click event is what we're most concerned with. So here this shows that we're looking to match click events on any paragraph element that has got a class with a class attribute with a value of arrow none. So that's kind of a standard match pattern. What is different again is this use of the IXSL namespace to indicate that on-click here is actually an event that we're listening for, rather than mode that is used within the code itself. And then we've just got some logic that handles this. And in fact, one thing I should say here is that this application was designed to work with tablet devices that are more touch oriented as well. And some of those don't behave very well with the on-click events. But instead you can use the touch end event. And so this template here is kind of a fallback in case on-click isn't actually handled. And there's logic here to test which case should be covered, to make sure that we're not handling the same, because there may be two events firing, but we only want to handle one. So it's to make sure that we don't handle the same event twice in different handlers. And then let's have a look at a different type of a DOM event that can occur, which is the key down event. And so this, we're using a match to match any element. So we're saying that wherever the focus happens to be when a key down event occurs, we want to handle that. But this is actually using further extensions, which are two extra attributes. One is saying prevent default behavior, and so that this is prevent default attribute with an IXSL namespace, and we're setting that value to yes. And then the other is the event property. So what that is that's kind of a further predicate on the match itself, to say that we're only interested in key down events on specific key codes. So what this event property attribute does is it says look for a key code property of that event, and then only match events that have a key code property of 13, 33 or 34, and they actually correspond to pressing the enter key, the page down or the page up key. And the reason why we have to have this special behavior for preventing defaults is because of well, it simplifies things for cross-browser compatibility, because Internet Explorer has got a different method for handling default events where you have to return false, which is not all that easy from within a template. So that's the way this is handled here. So within this template, we know that the only events that we have to handle are when these key codes are, when the key code is set to one of these three values. There's no more kind of exceptional detail to explain in this part of the documentation. So what I'll do is finish this session here, and in the next session I'll go on and look further at the files, and we can actually have a look at how the resources come together in the application folder, and how we deploy the application to the web server in a very simple kind of copy and paste kind of way. Thank you for listening.